Have you ever stopped to think about how some animals just vanish for months at a time and then show up again like nothing happened? Well, today we're going to dive into one of nature's most mind-blowing feats of survival, animal dormancy. Let's get right into it.
That is a great question, right? And the answer is even cooler than you'd imagine. We're about to pull back the curtain on how animals can literally hit a pause button on life itself, just to survive conditions that seem absolutely impossible.
You see, to get through brutal environmental stress, we're talking everything from bone-chilling winters to scorching droughts, a lot of animals have this incredible strategy. It's a state of physiological rest called dormancy. And honestly, it's nothing short of a biological superpower.
Okay, first up, the one we all know and love, hibernation. This is that classic, super deep, long-term shutdown that animals use to just wait out the cold winter months when food is nowhere to be found. It's a sleep so deep, it's basically suspended animation. But it's not just about surviving the cold. What about extreme heat? Well, for that, there's a warm weather version called estivation. You can think of it as a summer sleep. It's a way for creatures to escape that life-threatening heat and drought by going into a deep metabolic rest.
And then there's this third, incredible strategy, torpor. Now, this isn't about surviving a whole season. This is about surviving a single day. It's like a daily power down, a mini hibernation that some animals use every single night, just to save enough energy to make it to sunrise.
All right, so now that we've got the lay of the land, let's zoom in on that classic deep sleep of winter, hibernation, and the amazing animals that have absolutely perfected it. You know, for smaller mammals like ground squirrels or bats, this is a truly radical shutdown. When winter really hits, their body temperature can absolutely plummet by a staggering 20 to 30 degrees Celsius. Their metabolism slows to just a crawl, a tiny fraction of its normal rate, which lets them survive for months without a single bite to eat. But this brings us to a really fascinating debate, one that has puzzled scientists for a long, long time. Everyone thinks of a hibernating bear, right? But for years, the science was actually kind of shaky on that. Was the most iconic image of hibernation actually a lie?
So here's the deal. A bear's body temperature, it doesn't drop nearly as much as a tiny dormouse's. We're talking only about 7 degrees Celsius. Plus, they stay much more responsive. You can wake them up a lot easier than a ground squirrel that's in a deep, deep sleep. So, what's the final verdict? Well, after years of going back and forth, scientists now say with confidence, yes, a bear is a true hibernator. The reason they do it differently isn't because they're not fully committed, it's all about body size. It all comes down to simple physics.
I mean, just think about the sheer scale we're talking about. A bear has this incredibly large body mass. It can be 1,000 times bigger than a small hibernating mammal. And that massive size difference, it completely changes the rules of the game.
See, this is just brilliant evolutionary problem solving. If a bear let its huge body get that cold, the amount of energy and time it would need to warm back up would be insane. It would be a sitting duck. So that milder temperature drop, it's a crucial adaptation for a massive hibernator.
But hey, hibernation is only one piece of this amazing dormancy puzzle. Animals all over the planet use really similar strategies to survive another deadly extreme, intense, brutal heat.
And that's where estivation comes in. It's the perfect answer to a scorching summer. For animals like frogs and crocodiles, when the water all dries up and the sun is just relentless, they find a cool, damp burrow and basically enter a state of deep rest, a life-saving siesta to hold on to every last drop of water and bit of energy.
And then you've got torpor, the daily energy saver. Hummingbirds are the perfect example here. Their metabolism is so incredibly fast, they are constantly just a few hours away from starving to death. So what do? Every single night, they go into torpor. It's a metabolic nosedive that drops their body temp and slows their breathing down to just a breath or two a minute. It's the only way they can survive till breakfast.
This chart here just lays it all out so neatly. You've got hibernation and estivation, which are these big seasonal strategies for dealing with extreme cold or heat. And then you have torpor, which is more of a daily tactic to just manage your energy budget. Each one is perfectly tailored to the specific challenge the animal is up against.
So, the billion-dollar question is, how on earth do they do it? And maybe even more amazingly, how do they restart their bodies after shutting them down so completely? Let's get into the incredible biological machinery that makes it all happen. Well, the engine that lets a hibernating animal warm itself up super fast isn't shivering. Not at first, anyway. It's a high-performance biological heater, a secret weapon called brown adipose tissue, or, more simply, brown fat.
So what exactly is brown fat?
Well, unlike regular white fat, which we all know is for storing energy, brown fat is totally different. It is packed with mitochondria, the little powerhouses in our cells, and it's full of blood vessels. Its one and only job is to burn energy like crazy to generate pure, straight-up heat. And this diagram of the thermoneutral zone shows you exactly where this awesome mechanism kicks in. As soon as an animal's environment gets too cold and slips into that cold zone, just having a thick coat isn't enough. It has to actively make heat, and its first move is to fire up that brown fat furnace, its very own internal heating system.
So how does this magic work? Okay, in simple terms, when it's time to warm up, a signal floods the brown fat. This activates a special protein that basically hotwires the cell's normal energy factory. So instead of making ATP, which is fuel for the body, the whole process gets short-circuited, and all that energy is released as a massive, life-saving blast of warmth.
When you really step back and think about it, from the months-long slumber of a bear to the nightly power down of a tiny hummingbird, dormancy is so much more than just sleep. It's a profound, elegant adaptation for survival. It's a testament to the sheer resilience of life on this planet.
And this incredible adaptation leaves us with one final and really crucial question. These strategies evolved over thousands and thousands of years for predictable seasons. In a world with a climate that's changing rapidly and unpredictably, you have to ask, will these ancient survival skills be enough for these amazing animals to make it?